So hello and welcome everyone. So now we will be going to discuss this jumping on tiles problem, which is the problem C of Codeforces round 820, division 3. And basically what is given in this question, that we will be given some lowercase letters which will form a string, and we have to jump from the first position to the last position using minimum number of cost and maximum number of jumps. So what I mean to say is that first of all, let's understand what the cost mean here. So the cost will be equals to the index of the starting index and index of ending index you will be jumping on. Okay, so if I say that let's say I've given A and B. So from jumping cost of uh, AB, that if I want to jump from A to B, then my cost will be the value of A, which will be 1, and value of B, which will be 2. So it will be absolute value of A minus B, that will be 1. Similarly for A and C, it will be A minus C, that will be absolute value of A minus C, that is 1 minus 3, that is itself 2. Okay, so this is the term cost, which means here, so you have to use the minimum total cost, but at the same time you have to take the maximum number of jumps. So how are we gonna do it? And I've implemented it in a very simple way, so most of you will be able to understand this. And let's see how I approach this question and what are the observations to make in this question. So first observation to make in this question is that uh, in whatever move you move, okay, whatever the move you take, it will not change it will not change the minimum cost. So what I mean to say here is that let's say any string here. So if I see logic, so L will be 12 here and C will be 3. So always my minimum cost will be 12 minus 3, that is absolute value of 12 minus 3, that is 9. Okay, just pick up any case. Let's see this B C A. So B is 2 and A is 1, so my minimum cost will be again 1. So let's check for the third case. 1 2 and 3, so here my minimum cost is again 1. Let's check for the second last case. So it's A minus D, that is 1 minus D4, which will be 3 again. So here 3. So one thing we figured out that always the our minimum cost will be always our minimum cost will be s of 0 minus s of n minus 1, its absolute value. Okay, so uh, in any case our minimum cost will be this. So we did the first part of our question. Okay, so this, let's now go to the second part, which was using the maximum jumps, max jumps. And similarly we will see the third part. We have to print the sequence in which we are jumping, print sequence of jumps. So let's see how we're gonna do it now. uh, let's go with the very first example, that is logic. Here it is 12, 15, abc, 7, 9 and 3. Okay, so okay, so let's see how we're gonna do it. So we can jump from 12 to 9, from 9 to 7, and from 7 to 3, and its absolute value will be this, its total cost will be this, which will be nothing but 12 minus 9. Let's calculate it. 6 minus 3, 3. Okay, so 3, 12 minus 9, 3. Am I doing some mistake here? Or okay, 7 minus 3. Oh yeah, so here it will be 7 minus 3, not 6 minus 3. Okay, so here it will be 4 4 3 7 2 9, and 12 minus 3 will also result to the 9. So the thing is that we have to observe it to find this pattern is that we have to check that we have to see that if we are on, let's see if this is logic. So what we are doing that we are just jumping on the characters which are between these two characters only, that are between L and C. So O belongs from O is absolutely greater than L, so we are not be taking the O part. And if I go to the G, then G lies between L and C. Similarly, I lies between L and C. So basically, if you observe that we are jumping on L and C, and we can take any jump that is, let's see, uh, okay. So basically, we one thing we observe that we will be taking the uh, characters which will be between the starting and ending character. Okay. So now let's observe this thing with some other test cases. That is, let's take this BCA1. uh, it will be easy to understand now. Okay, so b will be 2, again this will be 3, and again this will be 1. So the minimum cost we can find is that 2 minus 1. So minimum cost we got is 1. Okay, so we have to pick the characters between b and a. So is there any character between b and a? There will be no characters between b and a. So we will do a direct jump from b to a, and that will be our maximum number of moves. Okay. uh, okay, so now let's see how we will implement this in our code, and what will be the conditions to implement it. So there will be basically three type of conditions, where the character at 0 will be greater than the character at n minus 1. This will be the first case. If I talk about second case, then character of 0 will be less than character of s of n minus 1. That will be second case. And character at 0 will be equals to character at n minus 1. That will be the third case. Okay, so let's start with the third case because it's very easy to understand. Let's see if I have this string, or let's say CDA, this string. So I know that my minimum cost in both the strings will be 0. Okay, and there is no possible minimum cost less than 0 possible in any of the string where these two characters is equal. So in case, now we have to see that in case of jumps, what we can do is, if we have to check that between the first and the last character, is there any character that lies between the first and last character? Well, all these characters are equal to those first and last character. So what we'll do that we can move from this to this to this to this to this, and the answer will be again 0. Okay, so we can make it count in our jumps, but here we will have to take this jump only, because we don't have any character that lies between this and this. Okay, so this will be the third case, which will be very easy to implement, I think. What you have to do is that you have to just calculate this amount, and you will just pick up this character, and you will just count its occurrence in the whole string. Okay, so the third part is I think clear, and now let's move with the first case, that is when s of 0 is greater than s of n. So LOGIC. Let's again take this example, because here L is greater than C, and what we will do that if this is greater than C, we will move in reverse order. For example, if I see A B C D E F G H I J K and L, so we will first go to the nearest character, which is to the L, that is I. Then from I we will go to G, and then similarly we will go to C. Okay, so in this order we will be moving for test case 1, for case 1, where this character will be greater than this character. And if I talk, let's say if I take some other example, that CIGOL. So here again the minimum cost will be 9, but the jumps will be somehow different. How it will be different, let's see. Now we will be moving from this side to this side. So between C and L, the closest elements to C is I. So we will first go to I, then we will go to, oh sorry, so the closest element to the C is G. So first we will go to G, then after G closest element is I, and I closest element is L. So this is the sequence of the jumps which will take basically from 1 to 3, 3 to 2, and 2 to 5. This will be the jump in this case. And if I talk about this case, so first will 1 to 4 to 3 and to 5. So this will be the uh, case in this. So I hope all the cases are clear. So basically we will be having three cases when this character is greater than this character, when this character is less than this character, and when the both characters are equal. So I'll show you the code, and it will be more than easy to understand. Let's see how I implemented this. So basically what I did was I took a string and I called my solve function, where I have implemented the three cases which I have explained. That is the first character one less than n minus 1, the first character which is greater than n minus 1, and the third case where the both elements will be equal. So let's talk about the very first case, that we know that amount will be always the last character minus first character. And what I have done that I have count the minimum jumps, starting the minimum jumps from 2, because we will be starting from the very first character and we will be ending on the very last character. So anyhow we have to pick two positions. So I started with the position number 2. What I did, I made a array list of pair. So what this pair class is about, that it will just store the values for and I have stored these values to keep the track that which is the closest element to the character from which I am looking for. Okay. And with it I am also storing its index in the one based indexing form. So this will be the whole code for storing the values with its indexes. What I did was that I have sorted the this list in reverse order. Why reverse order? Because if my character at first position will be 0, then I'll be moving from a state, as we seen that as we seen in the case this one, that we will be moving from this one, that we will be moving from C to G, then I to L. So we'll be moving in a straightforward direction. Okay. And I have sorted this. I have printed the amount and minimum, and for pair what I have did, I have printed all its indexes. And since we are starting from 1, so I have printed it first, and we are ending at end, so I have printed it at last. Okay. Similarly for second case, again the amount will be this, and minimum I started with 2. Again I made a pair. So here the check will be that uh, this character should be less than the this character, that uh, it means that the character which we are checking should lie between the first and the last character. And if that is so, we are incrementing the minimum, we are just adding the value as we done before. And here this time we are not sorting it in the reverse order. Why? Because as we see that we will be moving from uh, this side in the case when this character is greater than this character. Okay. So that's why. Okay. So one more thing I would like to show you, that I have implemented this pair class, and overridden this compare to method. And I've originally made this compare method to sort it in the descending order, that is from greater to lower. Okay. So this was the case, and again when I sorted this, I printed the amount and minimum. Again I started from 1, printed all the indexes in which order it is going to jump, and printed the last index. And the third and the final case, when both the elements will be equal, then the amount will be 0. And started with I just started with the minimum 1, and what I did was took the array list for the sequences, and it's a normal integer array list, because we don't need to keep such track that what will be the closest value, because we will be checking as we seen here, that if it is a, then we have to just keep the count of the occurrences of this first character. So I have done the same thing. I have counted the character, counted the occurrence of that character which is equals to the starting character, and I have pushed the indexes which are here in this, and at last I have printed it. Okay, so I hope you understand this question. Implementation was a little bit lengthy, I say, but the overall logic was very simple to observe. So make sure to comment if you feel any doubt here or in code. I'll be providing this code in the description also, so you can check it out. And thanks for watching.